Hi everybody. We are back for 8.5 notes. Today is essentially an extension off of 8.1. That's why we took another day to review it, but it has more algebra involved. So the key there is that we need to treat all, trig equations. And trig just means cosine, sine, tangent, all that good stuff. All trig equations, like algebraic equations. That's going to help us a lot. When we're stuck, just treat it like an algebraic equation. And again, our goal is going to be to get theta or x. Theta is usually when it's in degrees. X is when it's in radians. If you mix them up, it's not that big of a deal. I do it all the time. But our goal is to get that by itself. Okay, so let's start off with number 1. So we want 2 cosine squared theta minus 1 equals 0 for the interval theta is between 0 and 360 degrees. And the key there is degrees, telling us that we should be in degree mode, not radian mode, on our calculator. And again, you should have up that calculator that I posted yesterday. If you lost the link or you can't find it, I created a little Google link for it. If you type in gg.gg/Logan calc, that calculator from yesterday should pop up on your screen. Okay, so let's get rolling with this problem then as soon as I delete this. So like I said, our goal is to get this theta by itself. We're trying to get this alone. So if this said, again, we're going to treat it like an algebraic equation. So what if it was 2x minus 1 equals 0? Well, you would plus 1 plus 1. Then you would get 2x equals 1, divide by 2, divide by 2. X equals 1/2, right? That's easy. Well, what if it was 2x squared? Because it's cosine squared. 2x squared minus 1 equals 0. Well, this would be x squared. This would be x squared. Then we'd have to take the square root, take the square root, and we would get x equals the square root of 1/2, right? So let's do it now, but just keep it in terms of cosine. So we want to get theta by itself. Okay, plus 1 plus 1. 2 cosine squared theta equals 1. Get theta by itself, we need to divide by 2, divide by 2. Okay, now we have cosine squared theta equals 1/2. Now, it's kind of goofy. I said treat it like an x. Well, now it's cosine squared theta. Do you get rid of the cosine? Do you get rid of the squared first? You actually get rid of the square first now. So let's to get rid of a square, we're going to take the square root, take the square root. We get cosine of theta equals the square root of 1/2. Now, the only bad news is that's a little Sparta-y. So what we need to do is can you hear me? Okay, something weird popped up. Okay, never mind. I think we're good. What we need to do is rationalize the denominator. So this is 1 over the square root of 2. Okay, now can't have a square root on bottom. So what I'm going to do is, well, first of all, square root of 1 is 1 over square root of 2. To rationalize the denominator, I'm going to multiply by the square root of 2, multiply by the square root of 2. Okay, so 1 times the square root of 2 is the square root of 2 over square root of 2 times square root of 2 is 2. So I did forget one small piece, so it's cosine of theta equals the square root of 2 over 2. But remember, I took this square root, which tells me I need a plus minus there. Okay, so now this is asking for, and that plus minus is important because you'll remember from when we do our, this is before the shutdown, when we do our inverse functions, the inverse cosine is defined in 2 quadrants. It's defined here and here. Why is it defined in those two? Because we want one answer that's positive and negative. So cosine is defined in, the inverse is defined in the first 2 quadrants. Sine is defined in 1 and 4, as well as tangent. Okay, that's a little side note. But moving back to this problem now. So what this is asking us is, hey, where is the cosine of theta equal the square root of 2 over 2? We can do this one of 2 ways. Most of you probably recognize that one from your unit circle, which is good. So you can check your unit circle, but I want you to know how to use this scientific calculator that I posted so that when it's not on your unit circle, you can do that as well. Okay, so in order to get theta by itself, we would have to take the inverse cosine. So we get theta equals the inverse cosine of square root of 2 over 2, and it is plus minus. However, that plus minus we won't type in. So on that calculator, these are the buttons you need to press. I will write them down right here. You'll press the inverse cosine button. Okay, you are going to press the square root button. So it should look like this. That is 2 buttons above the 9. Okay, and then you're going to press 2. You're going to close the parenthesis right above the 8. You're going to press divided by. Then you're going to press 2. And when you press equals, then you should get 45 degrees. And that makes sense because on our unit circle, it is 45 degrees. That's what the cosine, the square root of 2 over 2 is the x value at 45 degrees. Now, I'm going to kind of go off of that a few different directions. And what I mean by that is, so that means this is 40. Oh boy. That means this angle right here is 45 degrees. And remember, we had a plus minus here. So we got to go, well, hey, in quadrant 2, cosine is negative, and that'll give us my negative answer if I use my reference angle and go up 45 degrees. So right here is 180. If I do 180 minus 45, I would get 135 degrees. So my two answers here are 45 degrees and 135. A lot of you are probably saying, well, Mr. Adler, I could have just went to 135 and saw that the cosine, the x value of 135 degrees on my unit circle is negative square root of 2 over 2. That gave me one positive and one negative answer for the square root of 2 over 2. Yeah, I understand that, but I want you to be able to figure it out using reference angles as well. Okay, so your two answers here, again, are 45 degrees and 135 degrees. Again, treat it like an algebra problem, get theta by itself. Okay, number two. Number 2 says sine squared theta plus 3 sine of theta plus 2 equals 0. Well, this looks goofy. Again, well, before we just said, well, what if it was just an x? I wrote this equation out that I'm about to circle in red highlighter. I wrote that instead of 2 cosine squared theta, I just put x. So I had 2x minus 1. So let's do the same thing. What if I did this as x squared theta plus 3x plus 2 equals 0? How would you solve that? A lot of you would probably just go, well, what if I went like this? Numbers that multiply to 2 and add to 3, it'd be x plus 2, and it'd be x plus 1, and it'd be equal to 0, right? Well, what if we did the same thing, but we did that with sine? So what if we said, hey, well, if I want to get a sine squared, I need to multiply a sine of theta and a sine of theta. What if I did sine of theta plus 2 and sine of theta plus 1? If you went and foiled this bad boy out, went here and here and here and here, and wrote all that out and combine your like terms, you would end up getting eraser, hopefully, you get sine squared theta plus 3 sine theta plus 2. So now, again, this is still set equal to 0. So if these two things multiply to equal 0, that's called the zero product property. If two numbers multiply to be 0, at least one of them has to be 0. So what I need to do then is just set this equal to 0 and this equal to 0. Okay, we get sine of theta plus 2 equals 0. Sine of theta equals negative 2. Well, Mr. Adler, that one isn't on my unit circle. Right, so what you need to do is go to your calculator, do inverse sine. Oh, got to clear it out. Make sure you press the AC button in the bottom middle to clear out your calculator. Okay, hit inverse sine of negative 2, hit equals, and it says error. That's because, look at your unit circle. The lowest the circle ever goes is down 1. So if I have a unit circle here, sine is the y value. The lowest this ever gets to is -1. That means this has no solution. It'll never go past -1, so it can't get to -2. Okay, let's do the same thing for the blue one. Sine of theta plus 1 equals 0, minus 1 minus 1. Sine of theta equals -1. Two ways to do this. You can use your calculator. So do inverse sine. Remember, to get sine by itself, we would take the inverse sine. Excuse me, to get theta by itself, we take the inverse sine. So theta equals the inverse sine of -1. So what is the inverse sine of -1? We get -90 on this calculator. Let's think about that. -90. Okay, positive is going around this way. So negative would be go around this way. If you go down 90, you end up right here. And that makes sense because, like I just talked about right here, the lowest we ever go on the unit circle is -1. Sine is the y value, so if I go all the way around, -90 is the same as 270 degrees. 270 is your final answer for this problem. Okay. On to number 3. This one says cosine of theta times sine of theta equals 3 cosine of theta for 0, or excuse me, theta is between 0 and 360. Okay, this is kind of goofy, right? Because we have cosines and sines here. Before, we just had all cosines or all sines. Now, when you have two different trig functions, the common mistake, and again, this is a mistake, so don't repeat that, is just say, well, I'll just divide both sides by cosine of theta, and those cancel out, and I'm left with sine of theta equals 3, and then I'm done, right? Well, kinda. So that's part of our answer. But when we do, remember, when we cancel things out, like if we have 3x over 3, or let's say, yeah, let's do 3x over 3. When we cross these out, we're really not crossing out. We're just saying that, well, this is really 1x over 1 because 3 over 3 reduces to 1 over 1. So those don't technically go away. They just reduce out. Okay, so it's this 3 is still there. It's just in the form of a 1, and we don't write it. And that's not a problem when it comes to numbers, but when it comes to trig functions, such as cosine, that becomes somewhat of an issue. So watch what we do instead. Instead of canceling them out, what we're going to do is, oh boy, this is going to get goofy. Oh, maybe not. Look at that. What we're going to do is we're going to move everything to one side. So what I'm going to say is, well, if I move this over, just minus 3 cosine of theta. Do it to the right, you got to do it to the left, minus 3 cosine of theta. We're left with cosine of theta, sine of theta, minus 3 cosine of theta equals 0. Okay, now you might notice, well, hey, I got a cosine here and a cosine here. In problem number 2, I factored, I treat it like an x, so I'm going to treat this like algebra. Could I factor out a GCF here? Do they both have something? Yeah, they both have cosine, so why don't I factor out a cosine of theta? And then in my parentheses, I'm left with sine of theta minus 3, and it's still equal to 0. Okay, now it's more or less the same as before. Before I had two numbers multiplied together to equal 0. Well, here I have two numbers multiplied together to equal 0. So all I need to do is set both of these equal to 0. Let's do the first one. Actually, let's do the red one first. We'll get sine of theta minus 3 equals 0. What I need to do is add 3 to both sides, get theta by itself. Treat it like algebra. Plus 3 plus 3. 3. Can't write. Sine of theta equals 3. Get theta alone. Inverse sine. Inverse sine. Inverse sine of theta. Cancel, cancel. Theta equals the inverse sine of 3. Now, I'm hoping many of you say, well, Mr. R, the highest we go on the unit circle is 1. So I can't go past 1. I can't get up to 3. So this is going to be no solution. If you didn't recognize that right away, what you can say is just, well, go to your calculator, inverse sine, 3, hit equals, error. So this one gives us no solution. There's no solution here. Okay, let's do cosine now. Cosine of theta equals 0. Get theta by itself, take the inverse cosine, take the inverse cosine. Okay, those cancel here. We get theta equals the inverse cosine of 0. Do this many ways. Think about it logically. Okay, cosine is the x value. So if I'm on the unit circle, and if left and right I go 0, excuse me, I'm going to end up, if I go 0, I'm going to end up at this point or this point. You can just look on your unit circle and say, well, here I have an x value of 0, 0, 1. Here I have an x value of 0 and a y value of -1. Or you can go to your calculator, clear everything out, do inverse cosine of 0, and you should get 90. So we actually have 2 answers here. The calculator only gives us 1, but your 2 answers should be this one up here, which is 90 degrees, and this one down here, which is 270 degrees. Okay, we are going to take 2 days of practice on this. I know it's a lot. I know it's new. I know it's a little more difficult.